Good day everyone and welcome back again to my YouTube channel. For today's objectives, we need to learn how to convert degrees to radian and vice versa, illustrate angles in standard position and coterminal angle, illustrate reference angle of a given angle. For our first problem, we will have to convert 135 degrees to radian. Our formula is radian is equal to degrees times pi over 180 degrees. Next, let's derive. So we will have 135 degrees multiplied by pi over 180 degrees. There's a degree sign over there, forgot to write it. Next, let's multiply 135 to the pi and 180 to 1. So we will have 135 pi over 180. That is 3 pi over 4. That is divided by 45, which is their lowest common denominator. So therefore, 135 degrees is equal to 3 pi over 4 in radian. Moving on to our second problem, vice versa. We'll have to convert 5 pi over 6 to degrees. Next, our formula is degrees is equal to radian multiplied by 180 degrees over pi. Deriving it, we will have degrees is equal to 5 pi over 6 multiplied by 180 pi over pi rather. We could cancel out the pi's, and we will have 180 multiplied by 5 over 6. So 5 multiplied by 180 is 180 multiplied by 5 is, we'll have 5 0 we'll have 900 over 6. So 900 divided by 6, we will have 900 divided by 6, we'll have 1, 6, and 6 is 3. Bring down 0, we'll have 5. 30, 0, 0 is 0. So we'll have 150 degrees. So therefore, Therefore, 5 pi over 6 is 150 degrees in degrees. Moving on to our second objective, we have angle is equal to 240 degrees. We have to find one positive coterminal angle and one negative coterminal angle. Okay, first let us draw our Cartesian plane. We have 180 degrees or 90 degrees rather at the quadrant 1. Quadrant 2 we have 180 degrees. Quadrant 3 we have 170 degrees, and quadrant 4 we have 360 degrees. First, we need to find one positive coterminal angle. So this is 340 degrees, which is our given angle. 340. Yeah, that angle right there is 340 degrees. Oh, I mean 240 rather, sorry. 240 degrees. To find the one positive, we will have to circle around it and stop at the given the given angle. So, finding the negative, we will have to go backwards and stop at the given angle again. Now that we have the graph, finding the exact value, we'll have to add 240 degrees, 360 degrees to find the first positive coterminal angle. So 240 plus 360 is 600 degree. And the negative one, we'll have to subtract 240 to 360, or we'll subtract 360 to 240 degrees. We will have, by subtracting, we will have negative 120 degrees. So this angle right here is 120 degrees, and the positive is 600 degrees. Moving on to the next one, we have our angle or theta at 30 degrees. We have to find one positive coterminal angle and one negative coterminal angle. First, let's draw our graph. Let's draw our graph right here and plot the 30 degrees, the given angle. 30 degrees must be right here, so that is 30 degrees. To find the positive, we will have to rotate counterclockwise from our x positive axis and land through the given angle, which is 30 degrees. And the negative, and the negative angle, we just have to rotate clockwise this time from our x positive axis. But first, let us add 30 to 360 to find the exact and degree of the first coterminal angle. So this angle is 390 degrees. So rotating clockwise, we have to stop again to the given angle. So this time we have to minus it from 360 to find its exact measurement. So 360 degrees minus 30 degrees is 330 degrees. So this is 330 degrees. 330 degrees. Sorry, I made a mistake. So this 330 must be negative. So we have to subtract 360 from 30 degrees, rather to subtract 30 degrees from 360 degrees to find the negative value. We'll have negative 330 degrees as our negative coterminal angle and positive 390 degrees as our positive coterminal angle. Moving on to our next and last objective and our fifth problem. Let's find the reference angle of 250 degrees. First, let's draw our Cartesian plane and plot 250 degrees at quadrant 3. 200, that is 250. Let's mark it 250 degrees. Up next, finding its reference angle, we just have to subtract 270 because it's in quadrant 1. You have to subtract 180 degrees rather, because it's on quadrant 2. Sorry for the mistake. So we have to subtract 180 degrees to find its referent angle that fall on the x-axis. So 250 minus 180 degrees, it is 70 degrees. So the reference angle of 250 degrees is 70 degrees. Next, to our last problem, sixth problem. We have to find the reference angle of 7 pi over 4. So first, we have to convert this radical form to degree form in order to find its reference angle. So 7 pi over 4 is equal to 315 degrees. So that is our degree form using the formula pi over 180. So let's draw our Cartesian plane and graph 315 degrees at quadrant 4. So let's assume that that is 315 degrees. Finding its reference angle, we just have to subtract it from 360 degrees because it is on quadrant 4. So 360 degrees minus 315 degrees, we will have 45 degrees. So therefore, the reference angle of 315 degrees is 45 degrees. But we have to convert it to radical form, radian form rather, because the given angle is at radian form as well. Yeah. So converting it, we just have to use the formula 180 degrees over pi, and we will come up with pi over 4. So the reference angle of 7 pi over 4 is 45 degrees or pi over 4. Now that we are all done, I hope you learned everything you need to learn in this video. Stay tuned for our next videos.